In this video, we are going to explore the various uses of visible light and ultraviolet light, starting with visible light, which is the part of the electromagnetic spectrum that human eyes are able to detect and is essential for our sense of sight. Visible light appears in a variety of colors depending on the wavelength, with red having the longest wavelength and violet having the shortest. A useful way to remember the order of these colors is with the phrase boy G biff, which represents red, orange, yellow, green, blue, indigo, and violet. Apart from enabling us to see the world around us, visible light also plays an important role in communication, specifically through the use of optical fibers. These are thin, flexible strands made of glass or plastic that are capable of transmitting light pulses across long distances without significant loss of signal. The light within the fiber reflects every time it hits the inner surface, which allows it to bounce along the entire length of the fiber without escaping. This process is known as total internal reflection. By encoding data into the pulses of light, we are able to transmit large amounts of information quickly and reliably over long distances. It is crucial, however, that the materials used in these fibers totally reflect the light instead of absorbing it, and the type of reflection must be specular rather than diffuse, so the light does not scatter and lose its direction. An alternative method of transmitting data would be to use copper wires and electrical signals, but optical fibers offer clear advantages, such as greater data capacity and reduced signal degradation or interference. This makes them ideal for modern communication networks, including the internet and telephone systems. Now moving on to ultraviolet radiation, which is located just beyond violet on the electromagnetic spectrum and has a shorter wavelength than visible light. The most commonly known source of ultraviolet radiation is the sun, which emits it naturally and is responsible for sun tanning and, in some cases, sunburn when skin is exposed for extended periods. In addition to natural sources, ultraviolet light can also be generated artificially using special lamps or devices such as sunbeds, which people sometimes use to give their skin a tanned appearance without sunlight. A more complex but fascinating concept related to ultraviolet light is fluorescence. Certain materials and chemicals possess the property of fluorescence, which means they can absorb ultraviolet radiation and then re-emit that energy as visible light. This is why fluorescent paints appear to glow so brightly. They are not just reflecting light like most materials, but are actually emitting visible light due to the energy absorbed from ultraviolet radiation. This principle is also used in fluorescent lighting systems. Inside these lights, ultraviolet radiation is produced initially, and this radiation is then absorbed by a layer of phosphor coating the inner surface of the bulb. The phosphor becomes energized and subsequently re-emits the energy as visible light, effectively transforming the ultraviolet energy into light that we can see. One of the key advantages of using fluorescent bulbs is that they are highly energy efficient, which helps reduce both electricity consumption and carbon dioxide emissions, contributing positively to the environment and lowering energy bills. Ultraviolet light also has important uses in the field of security. Special security pens can be used to write codes or markings that are invisible under normal light, but become clearly visible when illuminated by ultraviolet light. This technique is commonly used to mark personal property for theft prevention and is also implemented in official documents, such as passports and banknotes, to make them more difficult to forge. This capability allows for the easy identification of authentic documents and the detection of counterfeit ones. Finally, one of the very practical applications of ultraviolet radiation is in the sterilization of water and surfaces. Ultraviolet light can effectively destroy microorganisms such as bacteria and viruses, making it a valuable tool in the treatment of drinking water and in maintaining hygiene in medical and laboratory environments. This method is chemical-free and adds an extra layer of safety to public health systems. Anyway, that brings us to the end of this video. We hope you found it helpful and informative, and that you now have a clearer understanding of how visible and ultraviolet light are used in a variety of important ways in our daily lives. Thank you for watching, and we hope to see you again very soon.